Approximate numeric types are another option that we have in SQL Server, although honestly you rarely see them used a lot by most developers because we're kind of addicted to that integer data type, and it is exact. And if you go back to the movie on exact numerics, you'll remember that an exact numeric guarantees that we always get the same results from a computation under a lot of different conditions. Well, with a float data type, that's not necessarily the case. Now, you don't have to use quite as much data storage to store these, but if you've ever used a calculator set to floating point, you know what I'm talking about. Because sometimes when in an effort to store the data most efficiently, the decimal point will move around and you'll see some rounding on the data. And sometimes you can get away with putting a footnote on a report and saying difference due to rounding, but most people freak out when all the percentages don't add up to 100 or when all the various quotients or whatever don't add up to 1 or that sort of thing. And so a lot of people tend to shy away from float, but you can use float as a data type. The storage here is based on the precision that you ask for, and it's either going to be 4 or 8 bytes. And when you use float, you can specify that number of precision, and n can be from 1 to 53, and you're determining how many numbers of precision you can use in this decimal. And if you use from 1 through 24, you get 7-digit precision and 4-byte storage size. And if you use a precision number of 25 to 53, you get 15-digit precision and 8 bytes of storage size. If you're going to use float, I would just recommend you go out to Books Online and read about it and make sure you understand what's going to happen. But the main thing, without even going to Books Online, just know that if you use float, that when you divide things, for example, like 1 divided by 3, instead of getting a .33333333, you're probably going to end up with a .34. And so those kinds of things could present a surprise to you, especially in some scientific, financial type applications. So you want to be careful with these things. Now, the real data type is almost identical to the float data type, and the main difference is the storage size. Real always utilizes 4 bytes, and float, if you remember, utilizes 4 or 8. And so not a whole lot to say here. You have float and real out there. The decimal point can move around and rounding can occur. The computer does the rounding for you, and so you lose some control, and occasionally some of your calculations will come back looking slightly different. And if you can't live with this, then stay with the exact numeric data types. But the float and real are your 2 approximate numeric types that you have out there in your toolbox that you can use when and if you need them.